Okay, here we go. I'm going to only answer in this video A, B, C, D, E, and F. I've relabeled this original function instead of using the letter G, y equals. And from here down to here, we haven't used any calculus yet. We're just taking the natural log of both sides. The natural log of y equals the natural log of this expression. And now we're going to use properties of logarithms to simplify the way this looks. This is the natural log of a product, which equals the sum of the logarithms. And then we can use another property of logarithms that allows us to bring this exponent down front. And here's the way the log of y looks now. Now we take the derivative on both sides with respect to x. The derivative of the natural log of y is 1 over y times, using the chain rule, y prime. That's what we want to isolate right there. The derivative of 2/3 log of x is 2/3 times 1 over x times the derivative of the inside chain rule, but that's just a 1. The derivative of this is 1. Whoops, I forgot to put this 1/3 down front on this line. There we go. Oh no, I didn't forget to do it. Sorry about that. I did it here. So right here, 1/3 times 1 over 6 minus x times the derivative of the inside is minus 1. So I've rewritten this way. And now I multiply both sides by y to get the y prime by itself. And there's the value of y right there. We'll go to the next board. And you can look over what I did here. Pause the video. Take a close look at what I did. What I did was get a common denominator for these two fractions. There's the common denominator. Combine them. Then I multiplied by this y value and reduced the exponents in the denominator. Again, I'm not going to explain everything. There's your final answer for y prime. The critical numbers occur when the numerator equals 0 or when y prime equals 0. That happens when x equals 4 or when the first derivative is undefined. And it's undefined at 0, because I would be dividing by 0 here, or at 6. And here's your little number line chart for G prime. What I've done is, and there's the critical numbers, 0, 4, and 6. I've picked a test number in each interval, -1 to the left of 0. And then this little expression right here is just I visualize what the sign of the numerator in each factor of the denominator is. When I substitute -1, I get the opposite of -1 is 1. 1 plus 4 is 5. So the numerator is positive. The cube root of -1 is negative. And 6 minus a -1 is so the 2/3 will be positive. So the whole thing is negative. So the original function is decreasing. And I've done a similar thing on each of the remaining intervals. And find out that since we went from decreasing to increasing, we have a relative minimum at 0, comma g of 0, and a maximum relative maximum at 4, because we went from increasing to decreasing. At 6, we do not have a change in direction. So there's no relative maximum at 6. If I share my screen and take us quickly to Desmos, there is what the function looks like. You can see decreasing to 0, increasing to 4, decreasing for the rest of the way. The remainder of your problem asks you to find the second derivative so you can test for points of inflection and concavity. Left to the viewer, you will notice that we have a vertical tangent line here at 6. You can test that out with limits of the first derivative as x approaches 6. And here at 0, we have a cusp. The derivatives are not approaching each other from either side of 0. Okay, there you go. Hope that helped. you have any questions, post a comment. There you go.